Hello everyone and welcome to this video. All electrical conductors include a small amount of resistance. This resistance increases if the length of the conductor increases or the conductor size decreases. Think of blowing air through a hose. If the hose diameter decreases and/or the length increases, it would be harder to blow through. You can also think of freeway traffic as resistance. The freeway is the conductor. The wider the freeway, the faster and smoother you travel. As electrical current flows through the conductor, it experiences a decrease in voltage between the source, the starting point, and various points along the conductor. Another example to look at is the voltage drop in a 1,000-foot run of 16 AWG wire would be greater than that of a 1,000-foot run of 12 AWG. This is simply because a 16 AWG conductor is smaller in diameter than a 12 American wire gauge conductor. Fire alarm equipment listed to the standards of the National Fire Protection Association and Underwriters Laboratories UL is tested to determine if can operate properly at 85% of the rated nameplate voltage. This limit was set in place to make sure the circuit can deal with a brownout condition or a possible voltage drop, which might result from excessive resistance in the system wiring. Signaling line circuit voltage drop calculation confirms that the minimum required voltage reaches the last device on the power loop, even under worst-case load conditions. As required in the NFPA 72, fire alarm designers are required to prepare voltage drop calculations for the notification appliance circuits as part of the design. You as a designer can use several different methods to calculate voltage drop on a fire alarm circuit. One method calculates the overall voltage drop and the other calculates the actual voltage drop for each length of cable and device within the circuit. These voltage drop calculations must be included in the submittal plans and specifications. The suggested maximum allowable voltage drop on a fire alarm circuit is 10%, or the voltage drop included in the fire alarm control panel installation guide, whichever is less. Lump sum method. Step 1. Take the total current of the circuit. You can achieve this figure by adding up the current draw of each device on the circuit. This will represent A in the formula. Step number 2. Measure out the length of the circuit in feet. Do not double the distance of the circuit for 2 wire loops unless you want to use a multiplying factor of 10.8 versus 21.6. See step number 3. This will represent L in the formula. Step number 3. Use a multiplying factor of 21.6. This number represents the resistivity of copper conductors. This is a constant used in the formula. Step number 4. Find the circular mills for the particular gauge wire you are using. This can be found in the National Electrical Code, NEC, Chapter 9, Table 8. 14 AWG equals 4,110. 12 AWG equals 6,530. This will represent Cm in the formula. This formula calculates the total voltage drop, Vd, by multiplying the total current, A, by the circuit length, L, and the copper resistivity constant, 21.6, then dividing by the conductor's size in circular mills, Cm. This example uses the lump sum method to confirm that a 0.356 amp circuit running 450 feet of 12 AWG wire will result in a 0.530 volt drop. This final step shows you how to convert the voltage drop into a percentage by dividing the lost voltage, 0.530 volt, by the circuit starting voltage, which is 24 volts, and multiplying by 100, confirming this circuit has a safe 2.2% loss. Now remember, you can also perform this calculation for each individual segment of wire and each device on the circuit. This is known as the point-to-point method. It is a more accurate approach because it allows you to break down the circuit and identify exactly where the circuit should end due to voltage drop limitations. Next, let's explore the NSV Cabling app, a specialized tool for faster, more accurate circuit design and voltage drop calculations. Start the process by clicking Alarm Cabling command. A configuration form pops up, allowing you to define the key circuit parameters. Within this form, you gain full control over the circuit setup. You can define the circuit types such as loop, zone, sounder, and power, select your preferred unit of measurement like feet or meters, and precisely define circuit tags and all electrical parameters in the dedicated settings section. Cabling begins from the fire alarm control panel. From there, you will connect all the devices in accordance with the circuit class, the project design, and the site-specific requirements. As you connect each device, the software automatically assigns an address based on the device tag you selected in the draw cable form. In the lower left corner of the screen, you can monitor live data, including cable length, current, and voltage drop, giving you instant feedback as you design. The NSVCad Cabling app uses the point-to-point method for voltage drop calculations. The main advantage of the point-to-point method is that it provides accurate segment-by-segment voltage drop verification, ensuring that every device in the circuit receives adequate operating voltage, something the lump sum method cannot reliably guarantee. After finalizing your design, generate the riser diagram by typing NHRD in the command bar, then clicking on the fire alarm control panel to open the riser form. Configure the block count and device spacing in the dialog, and then simply click Done. With the NSV Cabling app, you can move beyond guesswork to achieve faster, more accurate, and fully compliant circuit designs. For detailed guides and product information, please visit nsvsoft.net. Thank you for watching.